Hi guys, this is lesson 7.8. Please note this key concept for geometric sequence. Please don't panic if it looks unusual to you because I will show you how to use it. First though, I want you to work through this review section. Number 1 asks you to underline the correct word, and it says to write a ratio in simplest form, the numerator and denominator must be divided by what? And a ratio is the same thing as a fraction, so hopefully you thought to divide by the greatest common factor. And if we do that on these problems, problem 2, your greatest common factor is 3. On problem 3, your greatest common factor is 2. On problem 4, your greatest common factor is 1, so that stays the same. And on 5, your greatest common factor is 25. So it goes into this one 4 times, and then I believe it goes into this one 9 times. Double check me on that with your calculator. Alright, so then we want to think about geometric sequence. The related words we already know are starting value, common ratio, constant value. The main idea is that a geometric sequence is a sequence of numbers where the ratio of any term to its preceding term is a constant value. All geometric sequences have a starting value and a common ratio. That just means they all end up getting multiplied by the same number. So, for example, the sequence 2, 6, 18, 54, it is a geometric sequence because the ratio to any term preceding it is 3. And all that's meaning is each term gets multiplied by 3 to find the next term. Alright, so this bottom section here just wants us to find the matching ratio to its geometric sequence. So on problem 6, to get from 2 to 4, we multiply by 2. To get from 4 to 8, we multiply by 2. From 8 to 16, we multiply by 2. So we can see we keep multiplying by 2, so their common ratio is 2. Alright, go ahead and pause this and figure out problems 7 through 10, and then come back. Hopefully this is what you came up with. If not, pause the video and check out what you did and see if you can figure out why. Alright, so for problem 1, it asks us to identify the geometric sequences. It asks what the following geometric sequences are. On problem A, we can see that they multiply by 10 over and over and over again, so the common ratio is 10. So that means, yes, it is a geometric sequence. Okay, problem 2 wants us to find the recursive and explicit formulas, which we have been given these in our books. The recursive formula is this one right here, and the explicit formula is this one right here. Okay, so recursive and explicit. Alright, so A sub 1 just means the first term. So notice our first term is 7. R is always the common ratio. So it's whatever the first term is being multiplied to get the second term, and so on. And if you can't see that in your head like we can with 7 and 21, you just go ahead and divide this term by this term. Okay? Alright, so since we know that a sub 1, or our first term, is 7, and we know our common ratio, we can go ahead and write these formulas. I'm going to put the recursive over here, and we'll do the explicit over here. Alright, so the recursive formula requires that we say where we start. So we're always going to say what a sub 1 equals, and then we'll follow that with a semicolon and go ahead with the a sub n. I don't really have room to write the whole thing right here. I'm going to write it down here. Okay, so I'm going to erase that guy. If you can write it all together on one line, it's better. Alright, so then we would just go ahead and say a sub n minus 1. So that just means that whatever term we're looking for, we take the term before it and then multiply it by 3. So this whole thing is your answer to your recursive formula, which you can see right here. Alright, for the explicit formula, we're going to say a sub n, which means whatever term we're looking for, and that will take the first term, so in this case 7, times r, which we found is 3, to the n minus 1 power. So for example, if we were looking for the fourth term, we would put 3 to the 4 minus 1 power, and 4 minus 1 is 3, so it would be 3 to the third power. Alright, so this is our explicit formula. Go ahead and pause the video and do problem 2. Problems 17 and 18 right here on your sheet. Alright, all of your blanks should have ended up with 2's in them. Our recursive formula is right here, and our explicit formula is right here. Notice you cannot just multiply this 2 times this 2 because order of operations says this exponent has to be dealt with first. Problem 3 shows us how to apply these to real-life situations. This example has 2 different managers at clothing stores creating sequences for marking down prices. So basically putting things on sale. The first manager chose this sequence of prices. The second manager chose this one. And our book would like us to find the recursive and explicit formulas for these, and then go ahead and say what the price would be after the 6th markdown. So basically, it's asking us for the 7th term because that would come after the 6th markdown. So to do the recursive formula, I'm just going to show you with the first sequence, and then you can look and see that they apply it the same way with the second sequence. The first sequence, well, maybe I will show you with both because this one has a common ratio and this one has a common difference. So we have a geometric on this side, geometric, and arithmetic or arithmetic on the right. Alright, so the sequence on the left, we start with 60 and we see we're going down at a rate of 0.85. How we find this is by taking 51 divided by 60, and that gives us 0.85. This one was not as easy to do on our heads. Alright, so, and we also know that our first term is 60. So that's enough information for us to be able to write our recursive and explicit formulas. Our recursive formula, we would say A1 equals 60, and then we would say AN equals AN minus 1 times 0.85. Okay, And it's not the n minus 1 that's getting multiplied by it, but it's this whole term here, a sub n minus 1 that's getting multiplied by 0.85. Alright, our explicit formula is going to be a sub n equals 60, because that's our first term, times our rate, which is 0.85, to the 7 minus 1 power, because we're looking for the 6th time this happens. Or, well, we're looking to be after the 6th discount. Alright? And this one is actually the most useful to us right now because we can plug in what we know. We can say a sub 7 equals 60 times 0.85, and then that would go to the 6th power. I'm sorry, when I wrote this before, this should have been an n. And then when we use it, it's a 7. Alright, and then we go ahead and calculate this out, and we get $22.63. The other sequence, the arithmetic sequence, the one with the common difference, we would have to go ahead and use the recursive formula that says a1 equals 60, a sub n equals a sub n minus 1 minus 8. And the explicit would be a sub n equals negative 8 times n minus 1 plus our first term, which is 60, which that's going to, again, be our most useful because we can just plug in 7 and calculate that. If we plug a 7 in here, I know I have negative 8 times 6, which is negative 48. And then we add that to 60, and we get $12. Go ahead and pause the video and work on problem 3 on your sheet. Okay, go ahead and pause the video here and check your answers. To graph, you can just write a t-chart with the xy, choosing values of x that are easy to graph. So if we plugged in 1, we get 6 times 2 to the 0 power. We know 2 to the 0 power is 1, and 1 times 6 is 6. If we plug in 2, we get 6 times 2 to the first power, which is 12, and so on. And then we just go ahead and plot them on the graph like they've done here. And then draw our curving lines with the arrows. Notice how this arrow right here does not cross the x-axis. Alright, pause the video and go ahead and try this area of your sheet. Alright, this is what you should have gotten. Notice these numbers here should each be on your graph, but it's very difficult for me to write that small with the stylus. Go ahead and finish out your sheet, and we will discuss this in class tomorrow.